Hello all, welcome to the next lecture in the lecture series on the Python and scientific Python course. Till now we have learned how to store and manipulate data using Numpy arrays, but in real world application, whether it is finance, research or engineering, we just don't store the data but we analyze the data. So today we'll try to answer the questions like what will be the average performance, how the data, how the spread out of the data is there in the given data set, how can we visualize and understand patterns. So this session is about statistics and visualization. So the first thing that we are going to learn in this session is to understand data through means. So mean is one of the statistical parameter which helps you to compute the average in the given data, right? So here let us now consider a simple data set, maybe like a one dimensional array. So import numpy as np, import numpy as np, then I'm creating my one dimensional array, maybe with the variable name dot marks, np dot array, which stores the marks of few. It's just a one dimensional array. I've created a one dimensional array. Now I wanted to know what is the average marks that is stored by these of all this complete one dimension data. So I'll have to use the syntax called np.mean to compute the average in the given array. So np.mean of the variable name that is used to declare the data. Okay, so here mean is simply the average, so it will be adding all the values and it will divide it by the total count. So mean is sensitive to extreme values. If I add let us just try np dot mean. Oh, I have a spell error here. So yeah, it's correct. Ah, this is missing. Array is not closed. That's okay now. Yeah, right. If I add a huge number like 500 to this and check, you could see that the average is too big, right? So if I have if the number difference between the values in the given array is having minimal deviation, no issues, but if there is a extreme sensitive value, then we'll have to face a distortion here. Okay, so the next statistical method of calculation, statistical parameter that can be calculated using npi, is to compute the median is a better middle value in the given list. Okay, so here let me take the same example, and here I have to, let me take the same example. I'll create a same one dimensional data, one dimensional array, and okay, let it be. And I need to calculate the median. So the syntax is np dot median of marks. Okay, so why is this median computation important? Median is robust because it is not affected by outliers. In real life analogy, if you have to correlate, if one billionaire is entering the room, average wealth will increase, but median does not change much. Median is always the middle value that you have after sorting. So if a billionaire comes into picture, average may increase, but this median will not change. It is because median is the middle value that is available after sorting the given elements in the array. Okay, now, if I have to understand how the spread of the data is available in the given data, one of the best parameters to analyze the spread of the data is, one of the statistical parameters to analyze the spread of the data is the standard deviation. Okay, so the same example you can take, and you just have to change the syntax from np.mean to np.std. Okay, so what is the use of having standard deviation? Standard deviation will tell you how far the values are away from the mean. Okay, if the standard deviation value is low, it means that you have some consistency in your data. If you have a very high value of standard deviation, it means that your data is scattered. Okay, right? Yeah. So here I could see that my standard deviation is very high of 164.8, and it is very obvious that my data is actually scattered. I don't have any consistency in my given data, right? So the next particular next concept is next statistical parameter is variance. Variance is simply the square of the standard deviation. We use it more in mathematical modeling of probability theory, indeed. So, like if you have to understand variance, you just have to change the syntax, like from np dot mean or np dot standard to np dot var. This will help you to compute the variance, which is nothing but the square of the standard deviation value. Okay. For example, if I have to calculate the minimum value in the given list, if I have to calculate the maximum value in the given list in the sense one dimension array or any dimension array, can use np dot minimum value of marks. Then I can use np dot max. Then I can use np dot sum. So this is how it will work. So minimum will tell you the lowest value in the given elements or the data, and maximum will tell you the highest value, and sum will help you to compute the total score. Means the total, the sum of the entire elements in the given list or the array. Okay. Till now we were working with example where you consider only single dimensional array. Okay. Now we'll see an example of two dimensional array. In two dimension, if you have to work with these kind of statistical estimation in a two dimensional array, the first and foremost thing that you should consider is about the axis. Okay, always axis 0 will point to the column wise elements, and axis 1 will go towards the row wise elements. The row wise will go across, column wise will go down. Okay, axis will tell you in which direction you have to travel through the uh, given data. Okay, so now let us see an example with the two dimensional array. Let me create an array with a name called data is equal to np dot array of sorry, I'm creating my two dimension data, right? Then I just close it, close the parenthesis. Now I wanted to print the mean value of this across column as well as across the row in two different sections. So I'll do np dot mean of data. Now it's high time that I should mention the axis. Axis is equal to 0. So this particular syntax will help you to calculate the mean along the column. Okay, similarly, print of np dot mean of data comma, now I define my axis is equal to 1. So this will travel through row wise. Okay, in a two dimensional, right? This is what you'll get the answer. Now we have to move in for transition to visualization. Till now we were working with numbers, all statistical parameters incorporated that were used to calculate the numbers. But it is always obvious that human brain understands pictures faster than numbers. So this is where Matplot library comes into the picture. Okay, so matplot library, we can just understand matplot library using few cases. Okay, so it is very well used for plotting plotting values. Okay, for example, we'll just start with understanding a simple question and its answer. If I give you 100 numbers, can you quickly understand the patterns of pattern in the given 100 numbers? Maybe it may or may not follow a sequence. If it is following a definite sequence, then it is quite easy. But if I give you 100 different random numbers, would you be easily able to understand the pattern of it? Not really, exactly. So that is where this visualization comes into picture. So matplot library helps us to convert numerical data into graphs so our brain can understand it very easily. So matplot library is a Python library used for data visualization. It allows us to create line graphs, bar charts, histograms, scatter plots, and many more. Okay, so usually we will import matplot library in this following form: import matplot lib.pyplot as plt. Okay, so pyplot is one of the most commonly used module, and plt is just a shortcut. Okay, so we'll use this in the line almost, it's all on all the visualization program we'll use it. Okay, let us start with a very simple plot. First, let us try to plot a simple line plot. Okay, I'll declare my data, which is a one dimensional array, right? And then I'm just going to plt dot plot of, sorry, it's dot of my data. Always I need to show the plot, so ends with show. Okay, so plt.plot will create the graph and plt.show will display. If you forget to use this particular syntax of plt.show whenever you're using matplot library, you will see nothing in the graphical output. Okay, nothing will appear. Okay, so you could see this. So as we did not mention anything over axis, it automatically takes 0, 1, 2, 3, 4 for the plots value. For example, if I change to some like some exponential values, you could observe the difference. Sorry, uh 2, 4, 8, then 16, then 32. So now you could see. Okay, it's an exponentially growing. It's, this plot is exponentially growing, right? So this is how you create a simple bar bar chart. Oh, sorry, simple one dimensional plot. Okay, sorry, simple plot using a one dimensional array. Okay, supposingly if I have to add labels and title to this plot, how will I do it? I definitely need to add it, right? So I can have plt dot title of, what should be the title of the plot? It's a simple plot. Then I need to give plt dot label for x, so it's x label. I need to mention what is it, index. And similarly I need to have plt dot y label. Y label is the values, y label values. And finally I need to show plt dot show. Okay, so without a graph without label is always meaningless, right? Sorry, now it will work. Okay, you could see the title of the plot, you could able to see the index in the x-axis label. and you could see the y label as values. Okay, so now we can go for a bar chart. Like, how will we construct a bar chart using Matplot library? Bar chart, let us create it with a few students data. Students, I can have it as a list. Okay, let it be the data and their marks. I need to plot them. Okay, so scores equal to 50, 60, 70, 95. So these are all their scores. Now I'm going to plot a bar chart. So that plot should be named as plt dot bar across two different values. One is students and the other one is scores. Then I'll use plt dot title of student scores, then plt dot show. Okay, open and close. Now, if we have to compare any categories, bar chart is one of the best way to compare. So this is very easy for me to compare the performance of student A, B, C, and D against their marks. Okay, so here I can add X label and Y label as well. So plt dot X label student, plt dot Y label as scores. Okay, right?